Alright, so here's another word problem. Here we're told the period of a simple pendulum varies directly as the square root of its length. If a 3-foot long pendulum has a period of 2 seconds, find the length of a pendulum with a period of 4 seconds. So, if we think about what's going on in this problem here, oops, sorry about that. We've got this pendulum that's 3 feet long, and for it to go back and forth, it takes 2 seconds to go back and forth. Now we have some other pendulum that in order to go back and forth, it takes 4 seconds. That's what's going on in this problem. And so the first thing that I would do if I were you is just common sense say, this new pendulum, isn't it probably going to be longer than 3 feet? In order for it to take longer to go back and forth, it only makes sense that it has to be a longer pendulum. You're not going to have a tiny little 1-foot pendulum that goes back and forth in longer time. That just doesn't make sense at all. You can't even picture that. So we know that our answer should be longer than 3, which immediately allows us to cross off A and B. Now, I'm going to go through how to solve this problem, and there's going to be a little bit of some steps involved in doing so, and that's okay. But if you had to get your quick answer to say, I need to put something down on this test and I don't remember how to do this problem, we could probably use some common sense logic that said, if the problem had just been directly varying, then doubling time would mean doubling the length. So if the problem just said that the period or the time varies directly as the length, then the fact that we doubled the time from 2 seconds to 4 seconds would mean we doubled the length from 3 feet to 6 feet. But that's not what the problem says. The problem has this extra wording here about square root of the length, which means it's not just a simple proportion of doubling one doubles the other. So I would say probably not this answer of D. So if I had to take a guess, an educated guess anyhow, my answer would be C in this case, which actually is the right answer. We're going to go through the math of that in a second. But I just want to walk through some common sense approaches to these word problems so that if you're stuck, you kind of have an idea of what your answer should be. So let's go through the math. Let's reread that first sentence, because remember, the first sentence in a variation problem allows you to set up the equation with nothing but variables in it. So we've got period and length as our two important variables that come up. So we're told the period of a simple pendulum, we come to this keyword varies. Remember, varies always means right equals k. Our next keyword we see is directly, which means multiply by the next thing that comes up. And the next thing that comes up is the square root of the length. So that's the first thing. Now we come to the second sentence. The second sentence gives us one full set of information that we can plug in so that we get all the values except for the k. So remember, k is what we're going to have to solve for. So if I plug in the 3-foot long pendulum, that's the length, and I plug in the period of 2 seconds, then I should be able to solve for k by dividing by root 3. Now, because this is not a final answer here, we don't really need to worry about rationalizing the denominator, but we'd plug it back in for the k that was in the problem. Now, you will notice in this problem here that if you had rationalized the denominator, that would have been option A. Obviously, it's not the right answer. K is never the final answer to any problem. It's just your constant of proportionality. Now, to finish the problem out, we need to actually answer the question. We're asked to find the length when the period is 4. So we plug 4 in for the period. And now we have some work to do. So now in order to get the L by itself, we need to get rid of that fraction that's in front of it. So I need to multiply both sides by root 3 over 2. So over here on the left, 4 divided by 2 is going to leave me with 2. So I have 2 root 3 over here. On the right, all I'm left with is root L. Now to get the L by itself, I'm going to square both sides. And again, something tricky happens though, because now on the left, I need to remember to square the 2 and square the root 3 separately, because this is really our power over a product rule. So we end up with 4 times 3, which is 12. So we got the actual answer of 12 feet through the correct math of it. But I think you can agree with me that going with the common sense approach saved us a lot of time, and we got the right answer.